Well, it's a great pleasure for me to introduce to you my second sound, Dan Gamota. Dan is the Vice President for Strategic Capabilities Engineering and Technology Services at Jabil Corporation. Now, Jabil, you might not know, but it's the third world's largest electronics manufacturer and the only American manufacturer. He has a PhD in material science and engineering and an MBA at Northwestern University. He holds over 50 patents. So take it away, Dan.
Most of that stuff my dad mentioned is in the past. And, when one looks back at his past, it's kind of interesting how I feel that I've gotten a second lease on life here at Jabil. And specifically manufacturing. So what I'd like to do is I know that there was a title for my presentation, and I'm more than willing to touch upon semiconductors and electronics, but I think it's more important for you to appreciate how important a company like mine is to really manufacturing and supply chain. And so I thought also it was very timely because for those of you that follow the electronics industry, we just finished having the biggest event, the global event, the Consumer Electronics Show, which is held in Las Vegas. And so I want to kind of orient you in terms of some of the products that we're building, but also kind of give you a glimpse of the future. So a lot of the things that you read about are going to be enabled by a company like mine, because most of the companies that are designing these products don't have the manufacturing expertise. And so my company, Jabil, think of us as an extension of a lot of the OEMs. I think for us, we're about, and I'll go into the introduction, but you'll see very quickly, you probably touch 10 products that we've manufactured during your day, but our name doesn't appear there. And so we are the company, the brand behind the brand. You name it, and you probably will touch upon a named brand that we build. And then just to give you kind of the footprint, we have over 100 sites globally. We have quite a few sites here in the US as well as on different continents. And really the location that we build products is options. Everything is done by the customer. The customer makes a decision where they prefer to build the products. We just basically make sure that we're successful and have the appropriate talent at that site to build the products. I have 4 teams. The teams are located in San Jose. Another team is located in St. Petersburg, Florida. Another one in Penang, Malaysia. Folks in Vienna, Austria, as well as others distributed across the world. And for us, we're on the front end. We basically are responsible for any new products that are going to be assembled. So if you look at Jabil, this is our size. It was mentioned earlier that we're the 3rd largest global contract manufacturer. Last year, we completed the year at about $29.3 billion. Earnings per share was about 5.61. You can see on the right-hand side, I mentioned 100 sites around the world. We have about 260,000 employees and about 50 million square feet of manufacturing space. So it's pretty impressive in terms of seeing how a company has been established with this scale by growing as other OEMs typically hand off the manufacturing to someone like ourselves who have the expertise. So with that said, if you look into our portfolio of products, you'll see that we're building products today that go into the mobility market, the digital print and retail, industrial and semi-cap, wireless and cloud, packaging, healthcare, connected devices, auto and transport, networking storage. And my responsibility is that a significant portion of these customers are introducing a brand new product. And the product is vetted by my team, not all the products, but basically if a product seems to be requiring different processes or materials or design methodology that doesn't exist, a BU, the business unit person will go and engage someone from my team to review the design, and if appropriate, engage our team to develop the industrialization process. Basically, it depends if the idea is coming from the customer and the idea is just an idea on a napkin, in which case then we are involved in the 18-month journey to take it from an idea to full-scale manufacturing. Or if it's simply a tweak in that the individual company has chosen to not use design rules that maximize quality, or they're using certain components that are difficult to secure, we'll make the recommendation for them to think of a different component, or we'll give them design recommendations and tolerances on how they can improve the yield of their product. So we're quite large. I will not be, in general, referring to companies simply because the companies, our customers, have asked us to be very discreet. But if there's a customer and if I show a product, I will mention who that customer is. So this is just another insight. The name of the presentation is Megatrends. And so my team's responsibility is to be able to understand what are the manufacturing requirements that are going to be necessary based on the intersection between megatrends, technologies, and markets. And so what I'm going to try to do is walk you through our approach on one of the sources that we use to be able to appreciate what are the megatrends and what are some of the products that we may be asked to manufacture in the near term, but all through the lens of a manufacturer. Everybody on my team has anywhere from 2 to 32 years of manufacturing experience. Many of them come from companies such as IBM, Motorola, Nokia, Applied Materials, you name it. These are traditional manufacturing companies that historically manufactured their own products, but over time, they basically decided to outsource to a company like ourselves, which has the expertise and has the focus specifically on manufacturing. That allows them to really go off and design products and make sure the products they're designing are successful from the introduction and from the business and market. So what I've done is we're going to look at the secular trends. We're going to look at some of the trends that you probably see on a daily basis. You probably are noticing that in your home while you sleep, where you work, where you drive and go someplace, you're noticing there's situation awareness. There's a significant amount of data that's being recorded by sensors. All of those sensors typically are bare die, so they don't have packaging on them. So we're getting closer to the silicon, the semiconductor world, or the gallium arsenide. So that's one thing in terms of semiconductors. Semiconductors, if there is something that's being sensed, chances are there's a piece of silicon. And that's why it's important for us to appreciate silicon and what the different growth opportunities are for silicon. But that's, you see it every day just by watching and walking and looking at people and looking at the equipment and products around you. Another trend, and this is the one that I'll do a deep dive in, is IoT and health monitoring and big data. And what I could say is that through our lens, a manufacturing lens, the last 18 months, we've seen in some cases trends that had been around for 5 years, and over 18 months and due to the pandemic, they were stress tested and they were realized that they are not going to be adopted by the mass market. In other cases, we've seen an acceleration. And so I think you'll see that there is an acceleration of health monitoring. There is an acceleration of IoT, and you will see big data, which is very important. I gave you 3 trends that we're following. One is cyclical trends for products. One is a trend associated with situation awareness and the ability to communicate with objects around you. And then the third trend I said was for IoT and health and data. Well, none of those trends would be realized unless a company like ours and our competitors were appreciative of the landscape associated with electronics. And so here, I just wanted to show you, without going into too much detail, everything starts as sand and ends up as a system. And if you're concerned about sustainability and circularity, there are routes to go back from the system back to the pure sand or silicon, and then usually silicon to go the other route. And so as you can imagine, you've started by going with semiconductor here on the left to OSAT, which is outsourced semiconductor assembly and test. And then ultimately you end up in our world, which is printed circuit board assembly. What we're seeing is there's a convergence. So in my world, I can't just focus on the right-hand side, which is printed circuit board assembly, which is pick and place of components. Many of you may know about through-hole. Many of you may know about surface mount technology. That's the high volume assembly. If you opened up your computer, you would see components that have been assembled or attached to a circuit board. As you go up the value chain, you begin to have dedicated clean rooms. You begin to have specific requirements associated with tolerance. You're working with 5-micron rules. You're not able to have contaminants. You're very cautious about things, but that's still in the packaging world where you're working with bare die. If you continue to go even further up the value chain, you're now talking about semiconductors and you're talking about fabs. And here you're talking about what today in today's newspapers and press you're hearing about is semiconductor and constraints. So this is the value chain. One looks at electronics. My company really plays on the rightmost side, and we start bleeding into the middle. While someone like a TSMC operates obviously here on the leftmost side, or someone like a Global Foundries or an Intel, they're talking about all the way on the left. And then just one last thing, for you to understand, the investments. Investments are billions of dollars. If you're a semiconductor fab, you're talking about $10 billion for a couple of assembly lines. If you are a company like myself, a printed circuit board assembly company, you're referring to about $10 million for an assembly line. So much bigger difference, 10 billion versus 10 million. Before I leave this slide, the one thing I want to say is though, even though cost is different, you need to have all of these pieces together. If you don't, you're having a disruption opportunity, and the resilience in the supply chain is going to be very hurtful to you. So when people talk about supply chain electronics, you really need to have all 3 of these pieces working together. If any one of these pieces is disrupted, And when I say pieces, I mean materials coming in, equipment vendors, people to come fix your equipment, and then of course your final product to leave your factory, you're going to have problems. And that's really what we're today dealing with, is disruption of this. But as you can tell, most companies are doing okay. In terms of advanced manufacturing, what I'll say is this part here on the left side, semiconductor, is the most advanced manufacturing facility you will see in the world, okay? Yes, it will rival with DNA-free bio and healthcare industries. Those industries will not have, again, you have to be without people because people bring contaminants. But in reality, as you move from the left to the rightmost side is really the most manual. There is automation, but there's a significant amount of manual labor. So by default, the leftmost side is the most advanced. The rightmost side requires the most labor. It's advanced, but it has a significant amount of manual labor. And so advanced manufacturing, when that is discussed in the realm of going from a physical world, which is semi-automated, and ultimately moving into a digital world where everything is done using data. You're able to basically take a physical line, and that physical line is created in the digital world as a digital twin, and then you're able to do everything on a computer screen before making outlays of equipment. And so now you can imagine why someone would want to do this, because if you can do most of your modeling in the digital world, you won't have to make investments in the equipment. You won't have to go through many physical assembly runs, and you can de-risk a significant amount of your design, your manufacturing, and ultimately your product performance. So when people talk about advanced manufacturing, it's really taking things that we do in the physical world and moving as much of it into a digital world to minimize risk associated with products launches. But all of that is great. And I'll tell you, we can have a talk about that because that's not going away. And that's probably front and center of a lot of conversations and a lot of approaches that people have today in terms of balancing supply chain. But I wanted to talk about what's really important to manufacturers. And what's important is I started out by saying that the Consumer Electronics Show is the biggest show. It's held in Las Vegas. It gives you a reality check as to what products are going to be launched in the next 6 months, as well as potentially what products could be launched in the next 2 years. And so the next few slides, I want to give you some insight into the Consumer Electronics Show. If those of you on the call who watched it, you probably heard that this year it was a hybrid. It wasn't all virtual. Last year was all virtual. This year was hybrid. But what we found this year was by going hybrid, we had a significantly better ability to go in and to review and to have dialogues with the people on show and understand what were the issues associated with manufacturing. So we weren't looking at what's going to be considered a adoption. Is it going to be if you're going to have first movers, if you're going to see adoption slow or fast or mass? We were just interested in the manufacturing. So I'd like to pause here before I get into the CES part, just so if anybody has questions about how we do trends mapping, or, our company or manufacturing, now's the time.
Okay, there are a few chat questions. And let's see. One is, I think it's a comment that Jabil began in Detroit and repaired circuit boards. I mean, that's how they
That's
took.
true.
And
It was started, the two founders are James and Bill. And they basically started fixing circuit boards. And then basically Bill Murray Sr. Asked his son to come back, Bill Murray Jr. And Bill Murray Jr. basically took Jabil to the next level. He moved down to Florida. IBM was one of their customers in Florida. And then another big customer later, a few years later, was Cisco. And that's why we, if you look, we have our first three facilities were Auburn Hills, Michigan, which we still have. We have a facility in St. Petersburg, Florida, where JDAS, Jabil Defense and Aerospace Space. And then you have the facility Great Oaks, which historically early on was Cisco, but now basically serves 20 different companies here in the Silicon Valley area. Good comment.
Another question is, are polymers becoming used in semiconductors?
So that's a great question. I would say that there's a wealth of knowledge around certain semiconductors. There are things such as single molecule pentacene, solution processable pentacene, which was reviewed, and we in a former life we were using it. There are polythiophene out there. The answer is they're not in mass, meaning that there are companies that have done, there was a significant amount of investments. There still is a significant amount of investments, but there really aren't, to my knowledge, a organic semiconductor that is in mass production. People are looking at different ways of taking the semiconductor. They are functionalizing some of them, and by functionalizing them, they're making them to sensors. I think those type of applications will probably see faster adoption. But yes, the organic semiconductor industry is stable, but it hasn't grown beyond the it's really more of proof of concepts and prototypes. It hasn't really gone into high volume manufacturing. It's difficult really to work against silicon and amorphous silicon.
I heard that almost 50 years ago, and silicon is still king.
And it continues to get less and less expensive.
Yeah.
Some of the products that I'll be showing, I can point out silicon, and I can point out the blending of organic electronics together with silicon. And that's really, that is one of the takeaways from this year's Consumer Electronics Show, is that we see this hybrid world that takes where silicon performs the best and where organic electronics perform the best, coming together and enabling a wealth of experiences.
Okay, another question: does Jabil have a presence in China?
We do. We have a presence in Clinton, Massachusetts. We have a presence in Auburn Hills. It really is dependent on our customers. Our customers ask us, the optionality is built upon customers make the decision where ultimately they want to build products.
Okay. And let's see, another question. Has Jabil made it very far in building digital twins as part of its environment? And what have the cost savings, speed improvements?
So we have not built a complete digital twin from product design to product manufacturing to product performance. So we do not have a digital twin per the definition by NASA of a product design, product manufacturing, product performance. We have instances of digital twins of one of those categories. It has, in the instances that we've made a digital twin, we were able to reduce the time associated with selecting the appropriate materials. We were able to use digital twin to optimize the process of solder paste deposition. We were able to build a digital twin of a healthcare product under operation and understand what could the limitations be. But we do not have a comprehensive digital twin similar to what you would hear about the General Electric fuel nozzle. So the General Electric, additive manufacturing metal fuel nozzle, that is the ultimate digital twin. But we do not at this point have that, but we do have elements of it. And actually, that could be another topic because, it's a long topic, but it's one that we are seeing the industry as a whole, the electronics manufacturing industry as a whole, whether it's the semiconductor world, whether it's the outsourced semiconductor assembly and test, or whether it's our world, the printed circuit board assembly, we all are collectively working together to build the architecture for a digital twin, as well as working with customers, or not customers, but in some cases customers, but a lot of cases suppliers that have also made investments. It is a significant investment to make a digital twin. And so collaboration and bringing people together to discuss it are probably going to be key over the next year or two. And there are a few activities being sponsored by the National Science Foundation and NIST and being hosted at universities where they're discussing digital twins as well as artificial intelligence to improve the digital twin.
Okay.
All these are good topics.
Yeah, last question before we get to Dan to continue. Peter has his hand up.
Dan, just a question for you. Some of us are old enough to remember the beginnings of computers and electronics as single layer circuit boards, with hand placed components and wires and all that good stuff. And today we don't see any of that. At some point, will you talk about Jabil philosophically and their involvement in the evolution of electronics, from the nascent start through current technology?
I can. Just tell me 10 minutes before I'm supposed to end.
And if you don't get to it, we can put that on the list for next time too.
Okay, but yeah, multi-layer, two-sided, embedded passives, interlayer dielectrics, yes, that
There's a lot
trend
there.
continues. Yeah, that trend continues. And obviously, miniaturization and high performance are the key points. But yes, definitely our aerospace customers are highly concerned about that. Yes. Okay. So this was the show. For those of you, Consumer Electronics Show. If you go back 20 years ago, it was actually companies like HP and other circuit board manufacturers that were allowing mobile devices to be commercialized. And so again, if you look 20 years ago, you would go into the Consumer Electronics Show in Las Vegas and you wouldn't see cars. You would maybe take a car to get to the show, but you would not see cars. You would not see robots. You would not see, you would literally see televisions, handheld televisions, and you would see the next generation cell phones and more cell phones. It's a different CES now, okay? And it's kind of interesting with the cars because, 4 years ago, it was all about the car. 3 years ago, it was not about the car. 2 years ago, it was not about the car. Now we're back to the car. And so it's kind of interesting. But the reason why I like this one is for those of you that have an ebook, a Kindle, that's actually what the skin of this car is. So the reason why the car is changing color is because e-ink has created a skin. So the outside of the car is actually the same material that goes into your Kindle. So basically it's an electrophoretic film, and the electrophoretic film has beads. Those beads have colorants in them. And based on a applied field, the beads or the colors either go to the surface to change, or they actually are flipped to give you the different shades of gray or black. So it's kind of interesting that, something that you hand hold, you can imagine that people are thinking about how to take electronics that you put in your hand and how to change the experience of your car. So kind of interesting to see it, but I just wanted to bring out that here you are seeing, electrophoretics, Kindles, basically liquid crystal technology displays coming together with automobiles. So the show was interesting, and the show was interesting because I don't know if you were watching it, but a bunch of the big boys and girls decided not to show up. And so there was a lot of concern as to who would be at the show and if the show would be entertaining and engaging. I can tell you that it was. I could tell you also that companies like mine basically had one person or two people on the show floor who now could walk the entire floor unimpeded. And basically all they had was, a cell phone, a smartphone. In the upper left-hand corner is basically the equipment. It's not a gun. It's basically a holder. It allows you to hold a mobile device and communicate. And so literally 2 cell phones, the holder, and a couple of AirPods, and you're on your way. At the show, everybody was following the mask mandate, but you could tell that everybody was very conscientious about ensuring health, safety, and security. These are just some of the companies that you would have seen at the Consumer Electronics Show. So you can see that there isn't the usual case, right? You don't see the companies that you would see on display at Best Buy. What you see is a portfolio of companies that are quickly integrating electronics in their product, or they're companies that are driving some of the trends I mentioned earlier. And what you can see is there's a significant number of automotive as well as healthcare. And now what I'll do is I'll walk through some of them. All right. Everybody knows about autonomous. And yes, autonomous was on display. And again, remember, the person on the, I was not in attendance. I was on the other side. So I was watching from my laptop in San Jose, and there were more people across our network connected, and we had individuals at the show, and we would look through the different people that were going to be showcasing their products, and we would ask for our friends and colleagues to go visit the different booths. And so what I'll do is over the next few pages, I'll kind of give you a glimpse of some of the products that appear ready for prime time in terms of manufacturing. The question is there truly a market? But in all of these cases, these are products that have gone through the initial ideation stage, they've gone through the prototyping stage, and they have some volume production. We start out in the left-hand corner, which is a company that is making e-bikes, e-scooters, and e-wheelchairs. The company is called Bird. In the middle is a company called Danar, which is a autonomous battery backup on wheels. So for those of you that are concerned about charging stations, here's a company that basically is offering its services in the meantime before you start having charging stations. Another one is, as you've heard, is the freight network, autonomous trucks. A lot of people consider autonomous trucks for transport of products as being the first large adoption of autonomous vehicles, and they were definitely on display. So here's a truck that basically could run autonomously between 2 points, and then obviously at the last mile on each of the edges, you would go into a non-autonomous life. So as you went closer to the delivery site, you probably would go to less autonomous to make this business product or proposition work. But you can see that people are thinking about, based on the constraints of autonomous, what are the opportunities for us near term. Bosch was on display, a significant number of scooters they were showing. We also saw drones. The carriage of drones was on display. The actual body of the drone, for the most part, I think we've kind of standardized. There are some differences in some of the drone companies, but really the difference for a drone company is the business model, and usually what is the carriage. Is it basically for optical inspection from a location that you can't go down, so maybe into a deep ravine? Is it maybe over an ocean or a part that is dangerous? But basically we saw drones, a significant number of drones, but really just the difference was what is their what is the interrogation that they're doing. We also saw delivery, autonomous delivery, which obviously would be a replacement or a opportunity beyond the Amazon trucks and USPS and other trucks. Space tourism, a significant footprint of space travel. Obviously, there was air transport. You had Snowbot. Basically, I know that you had a snowstorm a few weeks ago. So now you could have an autonomous snow removal. Indoor delivery bots. This is quickly taking on, but it's kind of interesting that, you know, we started the conversation about mega trends. Some of these were actually not considered trends, or they were considered nascent trends 2 years ago. But now, because of the world we live in and because of some of the constraints we have on the workforce, we're starting to see some of these applications take hold. Space satellites is another big one, but also what's the business model? Obviously, from our point, we would be interested in building satellites, which we do build. But the question is, you know, would we entertain this company because is their business going to take off? So, you know, everything I've discussed so far, we as a company don't really see a problem in manufacturing. It's more of a business model. John Deere, autonomous harvesters, you can imagine, you know, the future of a person owning several farms. They're sitting in their kitchen. In front of them, they have dashboards. They have video links. They're basically, all of their tractors on the field are operating autonomously, and they have all the data coming together into the kitchen table. It is real. It could happen. The question is, you know, who's going to be first to drive the business model? Underwater was a big theme this year. Again, autonomous underwater. And then the last one was the delivery bot, which obviously with everything that's going on. So nothing on these pages tell us that it's difficult to manufacture. It's really whether it's going to be adopted. And obviously the folks on the call are the ones that are instrumental in terms of whether it's going to be adopted. I did not hear too many people discussing the different levels of autonomous. It was more of, here's a great application of a autonomous vehicle. And as you know, at the end of the day, the different levels of autonomous are going to determine which of these products are going to be closest to the public versus which of these products will be in use, but it will be used in an environment that there is very little, very little connecting to people and humans as well as animals, just to make sure that the environment is successful. Fuel tech, unbelievable amounts of people discussing how are they going to basically recharge their batteries. So that was very big from charging. And then of course, people want to make sure that you don't use just trickle charging, but you have the option for fast charging. We also saw an entrance of hybrids, electric vehicles and hydrogen. And so here's a truck that basically, it's a platform, which is kind of interesting. They're looking at the platform, not necessarily what it's carrying, but now you can imagine that here's a platform of a drivetrain as well as the power electronics and the power source. And basically now you have something that you can reuse, kind of like a 18-wheeler. We did see hydrogen fuel cells, residential and industrial. So for those of you feeling that the the fight is over or the race is over, and that batteries are going to be the only winner. There are people that are looking for options where hydrogen could be a complement to lithium ion and different types of batteries. Battery management systems obviously is really important, and the ability to be able to make it as efficient as possible. Heaters, as you know, there are stories and there is data that shows that certain chemistries and batteries at cold temperatures, they do not first hold a charge, and second, they are not as efficient. And so they're looking at integrating battery heaters into the batteries to allow to operate most efficiently. And then printed batteries. We did see, although it's not a semiconductor, we did see some organic battery materials, and people are looking at uses of organic materials for batteries. Now I want to change gears and go into healthcare, because healthcare is a trend that has been consistent for 10 years for us. And it is also very dear to me simply because it's the next generation of the toolkit, the electronic designer's toolkit. Earlier, a question was asked about organic semiconductors. Another question was asked about circuit board technology. Well, healthcare is being driven today because of the coming together of organic electronics and new ways of designing circuits. They aren't multi-level circuits. These are usually single, one level. They may be double-sided, so it's two circuit layers, but in general, it's very limited in terms of the density. But it's unbelievable how many different products people are thinking of when you bring together flexible, stretchable substrates onto which you're printing organic conductors, perhaps a organic dielectric, and then you're attaching semiconductors. And the semiconductors are doing the computation, and in some cases, the semiconductors may also be doing the TX and RX, the transmission and receive. But the organics are what's allowing large area, and it's allowing the ability to become intimate with the body. So here we have miniaturization at its best. It's a glucose monitor. It's a continuous glucose monitor. Here on the right was the size of the glucose monitor a few years ago. This now is the size today. So you can see that they've made advancements in terms of making it smaller, making the electronics more sensitive, as well as adding data analytics to help remove the noise, because that is one of the issues, is that historically the signal that was received in the signature, the physiological signature, was noisy. And so now people are developing better algorithms. They're doing much more computation of the signal they record, and they basically are getting a much cleaner signal, but it's all happening because you're able to see more computation, more power in a smaller footprint. And obviously you're having a significant amount of design freedom because of the materials that you're using.
Is that inside the body or outside?
Excuse me?
Is that inside the body or outside?
So this one is outside the body. These have needles, okay? So this continuous glucose monitoring has a soft needle. Okay, this one here, so that's why it's invasive, non-invasive. This is looking at optical. So these are using optical sensors. So this glucose monitor in the center is using an optical sensor. So it's basically looking at your blood, and by using the image processing and looking at the reflection, there's a sensor that basically is able to determine the oxygen level in your blood. So the one on the left, there's a needle, and so that's invasive. This one is on your body. And the form factor is that of a smartwatch. You can also see we have AI and insulin injection. I'm calling out all of the words that cause a manufacturing engineer or designer to really become much more engaging, because you can see words like it, algorithm, AI. You can see, modular, wearable pump. Well, all of this, modular wearable pump, miniaturization, power supply, AI algorithm. Obviously, there has to be a data link or a data computation. So you can imagine that all of this is really challenging designers, but also is driving miniaturization and density, as was mentioned earlier by the circuit board. But in this case, there is no, to my knowledge, there was just a one-sided circuit board. I'll tell you something that has multi-side. Virus detection was obviously a big thing, as well as single room UVC air purifiers. So they were, I don't know if we have it here, but they had air purifiers, single room air purifiers that had an intake and an outlet of air, and then in between they basically had UVC sources that were radiating air as it was being flown through. Acoustics and AI is very big. Again, whenever you see a physiological signature, whether it's acoustics, whether it's optics, whether it's electrical, there is a significant amount of analysis that has to be done. And then the ultimate goal is to have a pure signal. And so obviously there's a significant amount of investment now being done using AI and personalization and knowing exactly what the signature for Jeff is versus the signature of Janice. So now you're starting to see this data coming together. But again, most of these products had no electronics. And so we're definitely seeing more electronics. Sleep monitoring was a big thing at the show. This device on this person's head is printed, and it's basically a flexible substrate. So this is probably either a urethane or a silicone, and basically they've printed onto it, and then it has organic material that comes into contact with the individual to provide the sensing. You have a ECG monitor. This is basically a flexible substrate. I think in this case, it was a polyimide, but there's no reason why it couldn't be a polyester, but it's a polyimide. Here's your sensor. The sensor is it has some liquid hydrogel. So the hydrogel basically provides the contact to the person, and then the electrical signal is passed across the surface. And I think in this case, it was a printed trace. So a printed, it was either silver filled or it was carbon filled conductor trace. And then in the center, you can see the box. The box is where all the electronics are. So this is a great example of flexible hybrid electronics, where in the center, you have the electronics, and then basically on the outside, you have the organic sensors. So here's the electronics and power, and here are the sensors. And this would basically go onto the person's chest. Here you have another ECG. Again, you have flexible material sensors, and then on the bottom is the silicon, the computation, and if in case this is wireless, you also have a chipset. And then obviously you have, if you're concerned about your dog and you're concerned about your dog's health, they also have basically wearables for your dog. All of these can be manufactured. The one caution I will say is the biggest thing that we've noticed is that the algorithm is what is the secret sauce. Most of these companies are definitely making investments in making the product to be more consumer friendly, that you can wear it at ease, that it's not very cumbersome. But the big issue is the algorithm that has been developed and is based on thousands of data sets, and being able to discriminate the data stream from noise to a anomaly that's detecting someone's having problems. That really is the next growth, is AI and algorithms, and being able to truly differentiate between noise versus a signature for the person. I want you to look at these, because now we're starting to see wellness and well-being. But for those of you that have probably watched and heard about metaverse, we're starting to see metaverse, because what we're noticing is that as electronics are being developed for healthcare, as electronics are being developed to be integrated in clothing, apparel, helmets, gloves, you're starting to see that blurring of the line between the physical world and the virtual world. So in the physical world, you would wear these type of devices, and as those devices collect the data, that data is going to be placed into the virtual world with your digital twin, which is operating in the metaverse. So all of a sudden, you're starting to see that the metaverse is not as far away as people think, and it's being driven by all of the knowledge and design and materials and manufacturing that's been done in the healthcare. So here is a helmet that has neurostimulators on the inside, that basically when you put this helmet on, it sits, it allows you, in this particular case, it was developed for depression release, but you now can imagine that you have a helmet and you have the appropriate form, fit, and function that is collecting data from your brain. It is now basically, trying to take that data and build a virtual digital twin, which you can now see your blurring of what is the metaverse. We saw earbuds, which is interesting, dehumidifying earbuds. So people who sometimes get water in their ears, you now have a dehumidifying earbud, so you won't get as many infections. Rapid COVID test, lots of them. We had monitors that could be put into clothing. We had urine diagnostic systems that be integrated into toilet seats. We had a robot table massage that looks very similar to surgical robots, which obviously are out there. We had breath analyzers. We had pressure therapy. This pressure therapy is another way to start behaving with the metaverse. You now have something that's body worn, but now you can imagine you're applying pressure to your skin, but you'll also be able to monitor that. So you have both an actuator and a sensor. And so now you can start seeing that clothing wise and apparel, you'll be able to have different clothing with actuators and sensors that allow you to interface from the physical world into the metaverse. And then obviously everybody, you know, is thinking of AI. What could it be used for? And here's just something that maybe you've seen, the artificial intelligence smart scale. So all of these, none of these wave red flags saying that there's something there that is making it impossible to manufacture. I think what you have is you have a portfolio of products, some of which are very easily built by robotics and automation. Others require a certain level of manual assembly. And so that balance is really what's important when you look at these products. We look at it from the standpoint of, are the bill of materials easy to get? Are they low cost? Is there constraints? And then the next thing obviously is this something that can be automated? Is this something that is going to be built in a hybrid environment? Or is this something that has a significant amount of manual labor where you need individuals that are highly skilled with their dexterity? And that's really kind of the learnings that we had here. This is something that we saw, immersion spaces. So basically, for those of us that, you know, are unable to or unwilling or don't have the ability to travel, we're starting to see, again, this is the metaverse in some regards. You're starting to see these were walls. These were 40-foot by 20-foot tall walls. And this was a safari. This was a company that basically, you can see up here, they have projectors. So they have projectors on the ceiling, and the projectors as front projectors onto these walls. We also, I don't show it here, but we had people that were using projectors to change the color of their wall, to change the look from brick to paneling to you name it, it's coming. So immersion, which again is an element of the metaverse, was definitely on display. And none of this is difficult. The question is it appropriate, and are people going to accept it? But yes, display on walls and immersion is definitely there. Here we continue the metaverse theme. Mixed reality training for the enterprise. So, you know, classes, obviously people didn't travel as much. We saw a significant number of companies that are offering mixed reality training. Historically, you may remember that mixed reality training was used for individuals that wanted to pilot airplanes. At this event, you saw a significant increase in content for training. We had training for trucks, we had training for airplanes, we had training for automation, we had training for manufacturing. A significant amount of content has been generated for training in mixed reality. We saw butlers, autonomous butlers, in all different form factors. Those of you up in the Northeast, obviously, iRobot is really, the God father, and continues to be the innovator and creativity spark for a significant number of robots and cobots dealing and interacting with people. We saw miniaturization. So we saw micro LED holographic displays, which was pretty big. So instead of having if you look, some of the displays are quite large. We now are starting to see things that are smaller, that have higher density battery sources, but also we're noticing that the electronics themselves don't require as much power. Smart gloves. Smart glove is definitely one of the anchors to the metaverse. You probably, if you go on YouTube and you look at some of the videos that have been uploaded from some of the companies leading the way, you see that smart gloves is definitely a topic that is receiving significant interest. What's nice about it is this smart glove is the material is either a textile, such as a woven or non-woven textile, onto which you print electronics. So you're printing either a silver paste or a carbon paste, and then you're using certain features to be able to act as a sensor. And then ultimately you connect it to an actuator. We saw in-cabin AR. We saw another glove, a smart haptics glove. So now you have feedback. So you feel as if you're touching something. We saw smart shelf inventories. But this is actually the coolest. This is the holographic HMI. So this is an interface that is holographic and has a haptics feedback. So he's not, in this particular case, he's not touching the surface, but he is getting a feel as though he's touching a button. And so the industries that really are looking at this are retail, ATMs, banking, as well as healthcare. So now you're starting to see this opportunity for some technologies to accelerate based on people's aversion to touching surfaces. And so holographic haptics was definitely on display, and we are seeing people pull. Sustainability, I could tell you that every single company is mentioning how sustainability is part of their design, is part of their material selection. Our company is very committed to sustainability. We just published our commitment to sustainability. I work as a manufacturing leader. I work very closely with the sustainability officer, but you can see that there are opportunities that people are looking at, and they are bringing things to market. In some cases, they're going to be attractive. In other cases, they may not, but you could definitely see. Here's a printed paper-based printed sensor. Again, it's paper as the substrate, but the material they print is an organic. I'm not sure, this may be a organic diode material, so not necessarily a semiconductor, but they may be using a diode, a material providing diode behavior. But you can see that definitely to the person who asked originally, we're seeing a lot of organic electronics, whether it's as a conductor, as a dielectric. We are seeing them in different functions. Do you hear her?
No,
Okay, I'll send it to you. It worked yesterday, but this is coming.
Check the
It's,
box and share your sound when you share your screen.
It's not something you can change right now. When you choose to share, on the right, it says share on the screen where you made your selection. On the left, it says share audio.
Dan, if it's important, you can stop the share, check the box and restart at the same point, because this is an independent presentation.
So you want me to do that?
Up to you. It's 11:18 and your time is what we're working against.
Oh, okay. So definitely metaverse is there. And you can see here's the virtual twin. You know, how close it is to him, I don't know, but you can see that there people are trying to say that, you know, there are digital twins in the healthcare industry. But there are also digital twins that people can build, which then at the show they're able to all right, so this is where we get into some of the electronics. But what I'll start with is IoT, health monitoring, and big data. If anything, the last 2 years have accelerated the adoption of technologies. It has also accelerated, you know, point of care and home diagnostics. Okay, you saw all the different healthcare products, and the one, you know, one common feature of all the healthcare products is a flexible substrate, a electronic device, as well as traces that must conform. And so now you're looking at organics versus you're looking at polymers instead of crystalline metals, and so now all of a sudden you're starting to blur, but the blurring and the acceleration is due to the fact that to be able to appropriately get a signal, you need to have intimate contact with the body. And what better way to have intimate contact but to have something that's conformal? And then obviously you need to have something that's compatible. So you will find silicones as being very common, as well as some urethanes. But as you know, some people, but you can see that in a lot of these cases, you'll have a region that is the silicon component, and then you have the sensing part, which is the organic trace. But you do have this hybrid, this blending of electronics that are not conformal together with the conformal electronics. These are coming. They are things that we've been watching for quite a long time. They're common. You may have an inhaler at home. There's a connected inhaler The connected inhaler ensures that, in general, it's all around compliance. So now by making a connected inhaler, people realize that you can ensure that someone is taking the inhaler at the appropriate time, as well as making sure they're holding it appropriately. So compliance is driving it. You saw all the different wearable biometric monitoring systems, all of it. You can see in this particular case, this is light therapy. Light therapy is finding a large growing market that electrical, acoustic, thermal, and basically light, those four help rejuvenate skin, as well as they do some interior improvements. I don't know all the specifics, but all I know is that people are asking my company to attach different sensors and different actuators onto flexible substrates like this person is showing. We also are seeing joints. So people who are getting they'll basically get a artificial joint that was printed using 3D printing. So here's a knee joint, and they, in addition to wanting it to be mechanical, they want a certain amount of electrical sensing and actuation. And so now you're starting to see people pulling together electronics together with products that historically had been physical, but then you're also seeing bundling of additive manufacturing to make sure it's a perfect match for you, as well as then putting in a circuit board and certain functionality. All right, so what is really driving all of this? And a person on the call, a chat asked about flexible hybrid electronics. Well, in a perfect world, and if we follow, Professor Alan Heeger and Professor Tobin Marks and some others who really are the individuals and innovators around organic semiconductors, we find that, yes, we were going to replace silicon. But the problem is it's very difficult on a component level to be able to get the functionality that you get today from silicon in a small footprint to achieve that same type of functionality on a same area for organic semiconductors. So then the question is, well, how about it, large area organic semiconductors? The truth is, yes, large area, that's really where organic semiconductors would do better. The problem is that amorphous silicon has come down so quickly that it's been difficult. But those are the kind of thought exercises that have to go when you choose. But in this picture, think of it flexible, conformal, stretchable, and think of it low profile, and you try to have the smallest footprint. That combination is what's driving miniaturization. And so earlier, this is actually the StarTech. This is the StarTech cell phone that I worked on back in '94. And I call your attention to because this is, I think this was an 8-layer circuit board, double-sided. So this is one side. You have a significant number of packaged components. But here in this picture, here's a flip chip. This was the 68338 flip chip, bare die. This was another bare die. This is the Bluetooth module, bare die. And what happened was that in the 90s, you had this acceleration of electronics. And I really feel that today we're going to get the same kind of acceleration with healthcare and flexible, stretchable, and organic and silicon, because the technologies on the circuit board were all being driven for one purpose: miniaturization, higher density, and mobility. And so people looked at a bare die flip chip versus packaged components. When I started at Motorola, it was T-SOPs, J-leads, and flip chip. If you look at a board today, there usually are no T-SOPs or QFPs. What you have are basically area array components where the attachments are on one side and it's full. The attachment is not on the edge, it's across the face. And where possible, you do use bare die, but in general, you don't use all of this packaging. All of the packaging has been removed, and you have truly the smallest amount of real estate, the lightest weight, and you have the least electrical resistance. And so now you're getting very high performing components, which is on this mega trend of miniaturization, lower parasitics, you're able to drive the components at lower biases. And so all of these technologies have not stopped. But what they do is they challenge the designer to come up with new design rules. And so this is a design rule for a printed display. So yes, this is a organic, these are organic driven pixels. And then this was basically printed driver. So this is a organic semiconductor backplane for display. And these are the type of tools that had to be developed for launch. But what I want to do is, I said this is truly a cross section of circuit board. All right. So we call it a flexible PWB, but it could be a flexible, it could be a FR4, it could be a high temperature circuit board. But you can imagine that the circuit board, where before a circuit board was one layer and maybe had through hole technology, so the leads of the components would go through the layer, you now have surface mount components. You sometimes have wire bonding onto the surface, but then you can see you have interlayer dielectrics, but then you start seeing that you connect each of the layers. And then if necessary, you also can connect to the other side of the board, and then you basically have fan out components. Or not fan out components. These are the ball grid array. This is the pattern that would go onto a motherboard. So basically, this type of design is very common in a silicon in packet, SIP, SOP type of package. And we can go into that detail, but I just wanted to answer the one question. There is a significant amount of complexity. Jabil does not. There are companies that are responsible for the stack up. And then these are the vias, they use layers. And then there are companies out there that build this printed wiring board. Jabil's expertise is attaching these components to the surface and doing it very well, high quality on a variety of different surfaces. So that's the other thing is yes, the printed wiring board industry is alive and well, and the value of the printed wiring board is significant because of the complexity associated with the inside.
Can you talk a little bit about the issues we're all reading about with parts shortages that cause all the empty shells for almost anything that's technological?
Yeah, so the shortages could be this, the printed wiring board. The shortage could be a capacitor. You know, I don't know why it's,
Is it affecting your company?
the answer is it does, but our company is at a scale where, and we have visibility of the supply chain to understand where are the constraints and what perhaps needs to be done to ensure that there isn't a limit. We do, this is where predictive analytics and the ability to pull in significant amount of data is very important. And this is actually one of the activities that the United States today, it was sponsored by NSF and NIST, and it was hosted in UCLA. They're looking at the ability to use AI to build a resilient supply chain for manufacturing. And so the belief is that if you are able to pull in all of that data, you can do a significant amount of predictive analysis to determine where are going to be your greatest potential risk. With that said, though, you're still going to have to be concerned about, risk associated with stoppage in the canal because somehow a boat was, turned. You're still, it's all about data and being able to go through the different scenarios. But with that said, every part of this was constrained at some point. The materials to make the circuit board, the solder used on the bumps to attach this large module to a circuit board, the components, the resistors that go on top, the microprocessor dies. All of these were impacted in some way or another. And then just remember, you have to test all these. So the testers, but within reason, you can do a significant amount of de-risking. And then the other issue is what we discussed about products. Part of the supply chain is the reliance on a supply chain sometimes is determined based on your design and your design rules. And so my group and a significant portion of my company is looking to improve designs. And when we improve designs, obviously we're improving designs to improve manufacturing yield, but we also are improving designs from the standpoint of which components are easier to secure. So part of the supply chain resilience is really around reviewing a bill of materials that the customer has and determining on that bill of materials which components are difficult to secure, which components may have only one supplier versus which components have multiple suppliers. Are the suppliers in a region that is going through a tsunami? Are the suppliers in a region that has a snowstorm? All of that information we have, it's not, some of our suppliers aren't able to give it to us, but that is the crux of the problem, is having a comprehensive view of all of the different nodes that come together to finish a product. That's really the opportunity that NIST and NSF and other manufacturing innovation institutes are focused on. There will be some kind of institute. It is being discussed by the Science and Technology Office in DC. The question is, how do you institute a framework and architecture, knowing that you're not going to have all the availability of the data you need?
Okay, Dan?
Yep.
It's 11:30, and I know some of the people have to leave.
Okay.
So I'm wondering if we can take maybe 2 or 3 questions, and that should be it for today.
When you were showing the pictures of the various autonomous vehicles, one kind of nightmare I had momentarily was what happens if somebody hacks into it and all of our supply chain of food and every other kind of good gets paralyzed.
I was surprised there weren't too many companies talking about security at the CES, but it may not be, security may be at other shows, but yes, I agree with you. There is a concern about security and hacking into these systems.
There's a question that I think all of us in this group probably are very interested in, and that is the point of view about practicality and timeline for implantable brain-machine interfaces. Sort of memory or whatever chip to put it into your brain. Anything like that?
I have not seen it come across from, I didn't, we didn't see it at that show.
But the
Just to,
helmet,
ju-
the
The
just
helmet
to
helmet,
gets
add,
close. The helmet gets close. Yeah, the neuromodulator. I mean, in your backyard. I mean, I know that there are some startups in Cambridge that are looking at that. I thought, wasn't Elon Musk, isn't one of Elon Musk's startups
yes,
Yes.
yes.
dealing with that? So,
The
but I have not
Neuralink.
seen it.
Yeah, okay.
And remember, our margins are 4.5%. Okay, so put things in perspective. 4.5%. Everybody else, dealing on these wonderful ideas is high teens going into the 20s. Big difference for us to investigate. So we spend a lot of time. All right, well, I appreciate you inviting me for this presentation.